Hello everyone, we're going to talk about reproductive basics. Welcome to Medical Diapers first of all, and today I'm going to talk about the SCG as a source. So SCG, human chorionic gonadotropin, produced by placental syncytial trophoblast, first appear in 10 days and peak 9-10 weeks, plateau 20-22 weeks. So SCG as a structure, it's a glycoprotein, has two subtypes, alpha subunit, beta subunit. Alpha subunit involves luteinizing hormone, follicular stimulating hormone, thyrotropin stimulating hormone, and for the beta subunit specific for pregnancy. SCG has three main purposes. The first purpose, maintain corpus luteum. Both the corpus luteum and placenta share the same function, which is the production of progesterone. So first of all, corpus luteum takes place, and after that placenta takes place in order to maintain pregnancy. After that, SCG regulate steroid biosynthesis in placenta and adrenal gland. SCG also stimulate testosterone in fetal male testes. So SCG in pregnancy occur around 5,000. So SCG in pregnancies generally occur around 5,000. And if it's above, it's excessive, and if it's below, it's inadequate. Excessive SCG, we see it in twin pregnancy, high density-deformed mole, choriocarcinoma, embryonal carcinoma, and inadequate SCG, we see it in ectopic pregnancy around 2,000, and the threatened abortion. Threatened abortion and missed abortion can be seen in adequate SCG. Here we have the HPL, human placental lactogen, as a structure is similar to anterior pituitary growth hormone and prolactin. As a pregnancy change, its level parallels with the placental growth. If it's high, HPL can be high, and they both rising throughout pregnancy. As an effect, it antagonizes the cellular action of insulin. So as we all know that insulin stores sugar, so if the utilization of insulin is low, we see glucose intolerance and diabetes. If the levels of HPL are low, threatened abortion and intrauterine growth restriction can be seen. In menstrual cycle, first of all, menstruation prolongs from 21 to 35 days maximum, and menstruation starts from the shedding of the endometrium of the uterus. And here we have the follicular phase. It starts from the maturation of the ovarian follicle till egg formation, and generally begins from the first day of cycle till ovulation. And ovulation, after follicular phase, we have ovulation, and in ovulation we have the release of the egg from the ovary, and also lasts 14 days. And here we see that the ovulation and luteal phase, they both last 14 days. And in the luteal phase, we see the thickening of the uterine wall, and after ovulation, here we see that the progesterone increases according to the fertilization. So if there is a fertilization, the progesterone increases in order to maintain pregnancy. If there is no fertilization, progesterone decreases in order to start a new cycle. So we have two precursors of steroids. The first precursor is progesterone. The second precursor is estrogen. The progesterone, as we already said before, produced after ovulation, luteal phase of corpus luteum, and it has the main function is endometrial secretory changes, and finally blastocyst implantation. So we can say that the main function of a progesterone in a pregnancy is blastocyst implantation. And the progesterone as a source from 6-7 menstrual weeks exclusively from corpus luteum, and from 7-9 weeks produced by corpus luteum and the placenta, and after 9 weeks exclusively from the placenta. So the production of a progesterone, first of all corpus luteum, after that corpus luteum and placenta, and finally placenta. And the purposes the purposes of progesterone, early pregnancy and in late pregnancy. In early pregnancy, endometrial secretory changes and blastocyst implantation, and late pregnancy, immune tolerance for the pregnancy, prevention of myometrial contraction. So it has the opposite effect of oxytocin, because oxytocin increases contractility and progesterone decreases contractility. And here we have three precursors of estrogen: estradiol along with single, so it's common in non-pregnant reproductive years, estriol common in pregnancy, and estrone common in menopause. So estradiol converted from androgen produced from androgen produced from cholesterol, and is converted from follicular theca cell to follicular granulosa cell by the aid of aromatase enzyme. So aromatase enzyme can be used in estradiol, and estradiol and aromatase enzyme converts from granulosa to estradiol by complete transformation. And estriol is common during pregnancy. 90% of estriol comes from a fetal adrenal gland, dihydroepiandrosterone sulfate, and converted by sulfatase enzyme in the placenta. So sulfatase enzyme helps dihydroepiandrosterone sulfates to convert to estriol. And lastly, we have the estrone along with alone. So it's common in menopause and also occur in postmenopause and peripheral adipose tissue, which converts adrenal androstenedione to estrone. And this is the end of the first episode. Thank you so much.